Hello everyone. Today we have an exciting exponential simplification problem. Let's look at this beautiful mathematical expression. 16 to the power of 6 minus 16 to the power of 5. This may look complicated, but I promise you, by the end of this solution, you'll see how elegant mathematics can be. So let's dive in. First, let's observe these two terms carefully. Notice that both terms have 16 raised to some power. The first term is 16 to the power of 6, and the second is 16 to the power of 5. Can you find a common factor here? So let's find it. We have a law, which we called law of exponent. It states that if we have a power m plus n, we can write it as a power m into a power n. Now apply it to 16 power 6. We want to break down 16 power 6 in a way that helps us factor our original expression. Notice that 6 equal 5 plus 1, so we can write 16 to the power of 6 equal 16 to the power of 5 plus 1. By using the exponential law, this becomes 16 power 5 plus 1 equal 16 power 5 into 16 power 1. Now look at our original problem, that is, 16 to the power of 6 minus 16 to the power of 5. And this, 16 to the power of 6 equals 16 to the power of 5 into 16 to the power of 1. Now it becomes 16 to the power of 5 into 16 to the power of 1 minus 16 to the power of 5. So, can you see what's common in both terms? Yes, it's 16 power 5. Now take 16 power 5 common, so it becomes 16 power 5 into 16 minus 1. Now, by simplification, it becomes 16 power 5 multiply 15.
Oh, we've reduced our problem significantly. Now, instead of calculating 16 to the power of 5 directly, let me ask you, what is 16 in terms of smaller numbers? Well, 16 can be written as 2 times 2 times 2 times 2, and it equal 2 to the power of 4. You see, 16 is actually 2 raised to the power of 4. This is crucial because working with powers of 2 is much easier in mathematics. So now, if 16 equal 2 to the power of 4, then what is 16 to the power of 5? Let me substitute 16 to the power of 5 equal 2 to the power of 4 whole power 5, and our complete expression becomes 2 to the power of 5 of 4 whole power 5 into 15. This substitution connects our factored form directly to a simpler base. We've gone from base 16 to base 2, which will make our calculations much more manageable. Now, we have 2 to the power of 4 whole to the power of 5. But wait, we have a power raised to another power. How do we handle this? This is where one of the most fundamental exponential identities comes in, power of a power rule. That is, b power m whole n equal b power m into n. It means that when you have a power raised to another power, you simply multiply the exponents together. Let me show you with a simple example first. 2 raised to the power of 2 whole power 3. It means 2 into 2 into 2 into 2 into 2 into 2, which equal 2 to the power of 6. That's 2 raised to 2 times 3, which equals 2 to the 6th power. Now, applying this rule to our problem, 2 raised to the power of 4 whole power 5 equals 2 raised to the power of 4 times 5. Let me calculate that exponent. 4 times 5 equals 20. Therefore, 2 raised to the power of 4 whole power 5 equals 2 to the power of 20. So, our expression is now beautifully simplified to 2 to the power of 20 times 15. You see how we've transformed our original complex expression, 16 to the power of 6 minus 16 to the power of 5, into something much more manageable? Now, we just need to calculate what 2 to the power of 20 equals. To calculate this, it might seem difficult, but Let's be smart about it. Look, we can write 2 power 20 as 2 power 10 times 2 power 10. We know that 2 to the power of 20 equal 1024. Therefore, it equals 1024 times 1024, or 1024 square. Now, we need to calculate 1024 squared. You might think, oh, that's a huge multiplication. But don't worry, I have a clever algebraic technique that will make it much easier. Let me break down 1024 into parts. We can write 1024 equal 1000 plus 24. So, is this help us to write in that format? Yes, because now we can use the binomial expansion formula. That is, a plus b whole square equal a square plus 2ab plus b square. This formula tells us that when we square a sum, we get 3 terms. The first number squared plus twice their product plus the second number squared. Let's apply this step by step. Here, a equal 1000 and b equal 24. The first term, that is, a square. So, a is 1000, and we can write 1000 as 10 raised to the power of 3. So, a square becomes 10 power 3 whole power 2, which equal 10 to the power 3 into 2, and it becomes 10 power 6. It means add 6 zeros with the 1, and it becomes 1 million. Now, the second term, which is 2ab. Here, a equal 1000, b equal 24. So it becomes 2 times 1000 times 24 equal 48,000. Now, the third term is b square. And here, b equal 24. So b square equal 24 square, and it equals 576. Now, we are going to add all the 3 terms. By adding, we get 1,048,576. By using basic algebra, we avoid to multiply 124 times 124 directly. Remember, our expression was 20 power 20 times 15, and we just found that 20 raised to the power of 20 is 1,048,576. So, now we need to multiply it with 15. Now, multiply with 15 directly might seem tricky, but let me show you a smart approach. Here, we will use the distributive property. Notice that 15 can be broken down as 15 equal 10 plus 5. Now, we are going to use the distributive property. That is, a times b plus c equal a times b plus a times c. Now, look how we use this. Consider a equal 1,048,576, b equal 10, and c equal 5. Now, let's calculate each part. The first part is a times b. Now, putting the value, this multiplication is easy because the number is multiply with 10, and a number is multiply with 10. Just add 1 0 to the number and we get the answer. So it equals 10,485,760. Now we are going to calculate the second part. That is 1,048,576 times 5. How do we multiply by 5 efficiently? Here's a clever trick. You know that 5 is exactly half of 10. So multiplying by 5 is the same as multiplying by 10, and divide it by 2. Or, in simple words, we divide the number by 2 and then multiply the number by 10. Let me show you. 1,048,576. Divide it by 2 and we get 524,288. Here we find half of the number. Now multiply it by 10. 524,288 times 10. Just increase 1 0 at the end, and we get 5,242,880. Now, add these two results together. We get 15,728,640. And there we have the answer to our problem. Thank you for watching. If you're interested in watching more interesting and informative videos, please like and subscribe to our channel.